We'll start today with Joachim, that came from New York directly for this conference. Thank you very much. He is the co-founder of Terraform One, associate professor and of practice at New York University. He is also he upholds noteworthily the leadership roles as a university senator and co-chair of the Global Design. So please help me welcome Joachim. Thank you.
It is super great to be here in person and not wear a mask for a minute. Okay, so I'm going to talk about the work that we're doing at Terraform One, a 501c3 nonprofit architecture and urban design collaborative in Brooklyn, New York. And a lot of the work that we do is very much fitted into this panel. There's actually so many friends here and colleagues who do amazing work, and it's great to see that, actually to see many of you in person. And we do need to keep doing more of this work. Our latest publication, which represents almost 15 years of designs and projects that we've been involved in on ACTAR, it's called Design with Life, and Maria Eilova and I had compiled all of the work and essays from many folks that are here. That represents this kind of new movement, which is very much about biology and architecture almost becoming, well, eventually becoming one. Because in reality, everything on this planet at some point was made by cells. Biology is technology, and architecture is morphing into a very new kind of field, certainly in its methodology. So what is it that we do as a mission? And I think this is crucial to the kind of understanding our work in relationship to the rest of society. We design against extinction. And I mean, this was probably the most profound statement we could prefigure or prescribe into the way we operate. Almost at the point of, there's some facts, if I can go through a couple of them. One is that every 9 minutes, another species on this planet disappears forever. That's every bird, fish, mammal, insect, it's gone. Since the 1970s, over 50 years, we've lost 60% of all species. We are headed, and I know this is a lot of doomsaying, but we are headed to be essentially equals to the Preammian Jurassic period, which was known as the Great Dying, which is where roughly 96% of all ocean life and 71% of all terrestrial life died off. Mostly because of carbon loading in the atmosphere. This is from volcanoes, so they didn't have a choice, but we do. And I think if architects have always been worried about a crisis, it seems like every decade, what kind of crisis do architects need to face? I mean, we're in a crisis right now with this pandemic. This is the mother of all crises. So one would think, how could we ever do anything that would be business as usual in our fields? We need to be accountable. We are all complicit. And I know many of us here make this as a distinct argument in our practices. So in some ways I am just preaching to the choir about this, but maybe we can do even more. Actually, we probably have to, because nothing is changing. We're not even slowing down. So one of the projects that we've done is about speculating about the near future of our cities. Here's the future of Manhattan. This is 42nd Street, where we have vertical axis wind turbines, photovoltaics that skin the surface of our buildings, gardens that are also on incorporated into our facades. They're there for air quality or for food production. Then we have a riparian corridor going through the center. We replace those shiny precious metal boxes and traffic known as cars with trackless trains in this case, and then leave the streets for these kinds of grand civic spaces with some idea of automation to help maintain this, as well as humans that would do that. This is just one polemic. It's not a, a utopia. It's just an idea that one needs to argue for, as this group here does, with our clients, with our patrons, with different institutions where we educate. So we don't get to this particular version of this future, but one that is very close to it. And that has many different authors collaborating to get us out of the problem that we're in. I think that's our job. So the next work, here's my daughter. Part of the answer is looking at different materials, biotech materials that'll do just this. So we can grow these things in labs. We started this laboratory called GenSpace with a roommate of mine from Harvard, Dr. Oliver Medvedik. So we had science collaborating next to architects, and we produced a chair. This is now about 12 years old. That was made out of mycelium and acetobacter, two different biomaterials fused together to make an industrially designed artifact that returns to the earth and feeds thousands of other forms of life. Not IKEA furniture, which ends up in a landfill, but this is materials that actually contribute positively to the ecosystem. It's also going to be made into various different types of architectural objects. And now, I mean, after all these years of working with it, this has become like a typical undergraduate student project, which is awesome to see that in the span of a decade or so. Another recent project we did was for the TED Countdown, which is giving us around 7 years before we see the permanent rise in temperature change, about 1.5 degrees, which makes it impossible for the oceans and coral life to survive. So there is a massive movement to communicate to the public what's happening to biodiversity. So we produce these eggs that get placed in social spaces. They're called Anti-Extinction Libraries. Inside it contains cryogenically frozen eggs of a species that's near endangered or on the edge of extinction or red listed, surrounded by seed bombs and all the different potential flora that it will need to survive. This egg slowly melts, made out of shape-changing materials over time. It eventually erodes, returns to the earth. The fertilized eggs inside get released, and that creature gets a chance to reset its population. This is not going to save, some of these issues with endangered species, but it will let the public at least get a clue and perhaps get on board with thinking about this as a problem that we all share. Another project we're looking at uses an amazing technology called the mealworm. In this case, it's an Amazonian mealworm, and it eats styrofoam. Styrofoam is one of the most difficult materials to get rid of on this planet. It's very hard to upcycle or recycle or move away from any kind of use into a better use. Here, this project was done for an unbelievably poor city in the United States, Camden, New Jersey, and it's a device that's both about science and architecture and installation. In the belly of that system there is a digester that allows the community to throw in their own styrofoam waste and then watch mealworms eat it up naturally. It does take a long time, but they digest it. They produce through the enzymes in their body a type of frass. They then eat that frass, and eventually the styrofoam disappears into garden mulch. And then the mealworms turn into darkling beetles, which are fed to lizards and other birds to help jumpstart biodiversity. Anything we could do to increase biodiversity is the goal. That's how we can kind of stop extinction. Here's another view through the top of it, the oculus, to get solar income down through the center. Another project we've been working on that is a wicked problem. This is also going on since my time at MIT, is looking at homes grown from living materials, or ELMs, engineered living materials. This case, it's clusters of willows. And we take these willows, which are used, in this case, they're farmed to produce energy or biomass. So you can find farms in the United States or parts of Europe, especially in Germany, that are growing willows to 3 meters in length. Then they're chopped down, pelletized, and they're burned for energy. And I think that's great, especially when you consider the alternatives, various fossil fuels, coal, etc. But here we can take it out of agriculture to make energy. We can also use it to go from agriculture to make architecture. So here we're using those willows into diagrids that are grafted together through scaffolding that controls their geometry and grow homes into the landscape where there is no distinction between the home and the landscape itself. It attaches to old growth trees that help support the structure against lateral loading. Another project we're looking at is food. So we work in waste, food, water, energy, air quality, mobility, all of these things are thought of together at Terraform. This is a project that looks at getting off of eating cows and pigs and chicken every day. In this case, our client was a cricket, or eating bugs. And the proposal is to eat bugs in Europe and the United States. The United Nations mandated that in 2013. We got to stop eating all of that meat. What's an alternative protein? Well, crickets are. For the same gram of protein you can get from cricket powder, you save around 2,000 gallons of water and around 300 times the amount of greenhouse gas emissions by eating cricket powder. You can make it into amazingly flavorful foods. So we work with Michelin-rated chefs to make bagels, bonbons, pasta, all made from cricket flour, and you could grow it inside cities as opposed to pastures outside cities that are industrially producing cattle. Here we make our insect powder to replace protein inside urban areas. Another project we're looking at is a way of thinking about going from pasture to plate directly so we can confront the food that we consume. Here, this is the urban farm pod, or the plug-in ecology. So this is a device that's part cabin, part furniture, part farm. You could grow your food on the inside or the outside. You'd grow things that are not necessarily stuff you can get on a large field elsewhere, such as wheat or corn, but here you grow spirulina, arugula, mince, and herbs and spices that you would then put into your salad. You can also use it as a place of respite and hang out inside it. There's a way of kind of combining different programs so that food and where it comes from is something that is not foreign to us. And then sort of just the last few projects. Here's the Butterfly Sanctuary, or the Monarch Sanctuary, produced for the city of New York. This client came to us and said they want to do a green building. We're like, well, there's lots of other green architects. We kind of don't care. We'll do a super green building if you want. And he said, all right, what does that mean? Well, let's stop a species from going extinct. In this case, it was the monarch butterfly. 90 million of these creatures have disappeared in the last few years. The U.S. Fish and Wildlife Service are saying they'll disappear. My daughters will not see these beautiful butterflies. So we fit into the skin of this building, in the facade, a vertical meadow that looks at the life cycle of these butterflies, their chrysalis stage, their caterpillar stage, egg-laying stage, how they mate, how they sleep, mud baths, etc. We designed different feeder systems. This was also done for the American Museum of Natural History. We did their insectarium project. Here, looking at how butterflies interrelate with their food sources and how humans can commune with butterflies. That's also important in the facades of our buildings. So you want to have a relationship between biodiversity and the occupants of the building. We produced a full-scale version of this facade for the Cooper Hewitt Smithsonian. So it's a working facade done with BASF. This is structural, made out of concrete, could last 300 years. It's the greenest concrete BASF had ever produced, and it was designed for the life cycle of monarch butterflies to keep them alive, to actually give them a chance to rewild New York City, give them a chance at just existing. They don't necessarily have a voice, but we could do better as architects. So there's actual monarchs in situ inside that double skin environment. And then finally, this is very much about responsive cities. We were looking at using, everything we do as architects at Terraform has been working with living organisms. So in this case, it was using transgenic E. coli that we modified to create this kind of analog computational system to show the growth of cities over time, to explain human population growing towards the end of the century. That's around 11 billion of us. How are we going to live? What are we going to eat? How are we going to move? And how do we even conceive of what that might look like? So we produced this BioCity map, which we use the E. coli to map the same populations in our 50 largest cities and show what that looks like increasing over time. Also shrinking cities. It's parts of the middle of the United States and parts of Europe where we're losing population. So here's a map that shows the world as one contiguous city growing through living E. coli. And finally, this last project is another ELM, engineered living material, that combines CLT and mass timber to produce this kind of centerpiece for the largest urban park going up in the world, which happens to be in Riyadh. This is the largest park ever proposed in history. us and many other architects are working on some of the structures there. Here we're building a structure that is a vertical farm on the inside, and the outside is made up of infill that's all living materials. Here it's Ficus sycamoris that is grafted into a specified geometry through computer-driven scaffolds that grows on the surface of the building and integrates to gardens in and around that building. All of these gardens are local species, they're drought resistant, etc., and are meant to show a building that is very much alive and stays alive. And the inside is about growing food for the people there inside Riyadh, and giving them a sort of educational tour of how we could change the way we farm and how we could do it sustainably. I know I'm out of time, but that's just some of the work we've been up to, and I look forward to the discussion after. Thank you very much. Thanks, guys.